Alright, this is your video for 11.5. This is where chapter 11 starts to get a little bit tricky, not because the information's more difficult, but just because all those theorems kind of start to add up and they all start to run together and look the same. So you really have to use your formula chart to discern the difference between 11.4 theorem and 11.5 and just make sure you're really using the right theorem and following it precisely. Alright, so this first example is based on 11.5.1, which is similar to the inscribed angle theorem. These aren't inscribed angles, but it works the same because if the vertex is on the circle, whether it's an inscribed angle or whether it's a tangent, meaning a chord, it's the same property, that same half-double relationship. So if the arc for FH is 130, then the angle EFH would be half of that, so it would be 65 degrees from that relationship. So the difference between this is an inscribed angle formed by two chords that intersect on the circle. This is just an angle formed by a chord and a tangent, but it still intersects on the circle, so it still has that same property. Okay, you try B. Alright, B is the same theorem, 11.5.1. If this is 122, then the arc that it subtends is 244. Okay. Example 2. Both of these right here start out being theorem 11. Whoopsies. Theorem 11.5.2. Now this is the intersection between two secants or chords, it doesn't matter which, is happening inside the circle. So notice this isn't the center of the circle like a central angle, these are just meeting somewhere in the middle of the circle. Not on the circle, not in the center, just in the middle. And that theorem says that the angle in the middle is equal basically to the average of the two arcs that it creates. So in this case, we're going to put angle AEB, and he's going to be equal to half times the two arcs that are formed when you intersect. So 139 and 113. And in this case, you can just kind of tappy that right out. So that would be 126. So this is going to be 126. Okay. Let's go on to part B. Find the measure of angle AED. Well, that one actually doesn't have anything to do with circles. If this is 126, then AED, that's his linear pair. So 180 minus 126, what is that, 54? You'll have to excuse me. Yeah. Alrighty. Moving right along here. Okay. Example 3. This one is based off of theorem 11.5.3. This theorem is if the intersection of two secants happens outside the circle. So we've gone from intersecting on the circle to inside the circle to now outside the circle. And this one has the relationship where the angle is equal to half of the big arc minus the little arc. So the big arc's always going to be the one on the outside, and then the little arcs are going to be closest to the angle. So I don't know the angle, but I know it's half. The big arc is 87. The little arc is 7. So I know x is equal to 40. Okay, pause here and try B, which is exactly like this. Same thing, still 11.5.3. Let's zoom in on this side. So this one, same story, 200 minus 74 is 126, so that would be 63. The other way this presents itself is if I give you the angle but not one of the arcs, you're still going to set up the equation the same way. It would just take a little bit more solving. Could also introduce quadratics into this solving, and it would be, the geometry would be the same, but the algebra can get increased at any time. Okay, example 4. I'm just going to have to zoom back out. in the company logo shown, the measure of arc FH, so from here over to here, is 108. And the measure of arc LJ is 12. What is the measure of angle F to K to H? So even though there's these other lines in here that start making this circle look confusing, I actually don't need these. This is that same theorem 1153. Because the intersection is happening outside the circle, then the formula is the angle equals half the big arc minus the little arc. So 108 minus 12. So the angle is equal to 48 degrees. Pretty easy on that one. Okay, so I do want to point out here on your, maybe, in your book, it does kind of go over these three theorems all at the same time and point out the differences between them. So you can see if it's on the circle, then it's half, the angle is half the arc. It's hard to see, but this is in your book. If the intersection is inside the circle, then you're going to do the average. You're going to add up the two arcs and divide by 2 to get the angle. If the intersection is outside the circle, you're going to subtract the two arcs and divide by 2. So once you can kind of see a chart comparing all of them at the same time, then it doesn't get quite so confusing. Alright, last one, the last two I guess. Example 5 is when we're going to start using these kind of together instead of just one at a time. So let's see what we have going on here. Oh my goodness. Okay. Find the measure of arc YZ is what I'm after here. Alright, let's look and see what I can do. Well, that's okay. Alright, this arc YZ, he corresponds with angle X, and angle X has an intersection outside the circle, so I could use theorem 1153 if only I knew the measure of this arc from here to here. So let's just start playing around with this and see where I can get. If this is 113, then this is going to be 67 because these are a linear pair. Now I have this interior angle right here, and I have one of his arcs, so I can use theorem 1152 to get that arc that I was just talking about. So if the angle is 67, then that's going to be equal to half of 68 plus the arc that I was trying to find right here. Okay, so 134 is equal to 68 plus x. I just multiplied by 2 to get rid of the 1/2. What was I doing? 68. So x is equal to 66. So this arc right here is equal to 66. And now I can use theorem 1153 and do the exterior angle. So 49 is equal to half the large arc minus the small arc. So again, we've got 98 equals the large minus 66. And the arc YZ is going to be equal to 164 degrees. Now this isn't the only way to work this problem. There's a way where you could have found all the pieces except for this and done the minus 360. There's a couple of ways to do this problem. This is just the one that jumps out to me first. So these are going to use a lot of stuff that we've used all chapter and even things back into chapter 2, or 1 rather, to help us get this done. So a lot of work into 1. Alright, pause here and try B. B is a little less complicated than A. Because this is an exterior angle out here, this 26 which is how I read that. And now that I look at that, that could just, yeah, I think that 26 goes with the measure of angle Q. So then I solved that, and I got that PR had to be 28 when I used theorem 1153. And then if the whole arc LR is 100, then I take out that 28, and that must have been 72. Okay, see ya.